Hello, this is first video on greedy algorithms. Let's discuss some basics and some questions. So given an array, find the maximum product pair in the given array. So return the maximum value of vi into vj such that I is not equal to j. So simply we can just try to traverse the loops and we can enter the maximum value. But really, do we have to try all the pairs? No. So let's take a sorted array, for example, for simplicity. So it will be minus 5 to minus 2, 0 and 1 to 4. So all elements right to 0 are positive and left to 0 are negative. So we want the maximum possible pair, right? So obviously if we try to return a pair with a positive value and negative value, that product will be negative. So the answer can be negative only in one case, when the size is 1 and the negative element is there, and size is 2 and the first element is positive and the second element is negative. So only in these two cases the answer can be negative. In any other case the answer will be positive. So ignoring this case is better. Now let's come to positive positive or negative negative. So product of these both is positive. So let's try to discuss about positive and positive pair. So if we are trying to return a pair with positive positive, which two numbers are better? So taking the highest two values are better, because they are highest and the product will be also highest. So it is 12 and it is greater than any other product pair possible. And similarly, if you are trying to return negative and negative, surely it is better to take the least two ones, because the we can get the positive sign, and as minus 5 is less than minus 4, these magnitudes are greater than all other negative values. So taking the least two for the negative or taking two from the highest values are positive are better. So finally we can return the maximum of these both as answer. So did we try for all pairs here? No. We tried only for highest two in the positive and least two in negative. So this is greedy. Instead of checking all possible ways or methods, we greedily observe some observation, assumes observation that it is correct with a hope. So we have to try for a proof so that it is actually correct. So here we are sure that it is correct because we saw some examples and we can easily prove that product of this is higher than any other possible pair as well in positives. So let's take another one. So given an array and given another number x, add x to any element. Finally, we have to return the product of elements in the array. So for example, if we are adding x to v0, the value should be v0 plus x, v1, v2 and so on. So this product should be maximum. So let's check two values for simplicity. And if we try to add x with a and x with b, there are two cases. So for the first one, it will be a plus x into b, it will be ab plus abx. For second, it will be a into b plus x, it will be a plus x. So adding x to a is better. It means that ab plus bx greater than ab plus ax, because we assume that it is better. So when it is better, when it is actually greater than the second one. So when it is greater, it is better. So by solving this, we can get b greater than a. So adding x to a is better if b is greater than a. And similarly, x to b is better if a is greater than b. So we have to add x to the least value, because if a is greater than b, b is least, so we are adding x to b. So we have to add x to least value. Why is this? Say let's example, these are two values, and if you are trying to add with the least one, the product will be this into this as well, because this is the highest value. And similarly, if we try to add the x with this, the product will be only this into this is extra. But here the highest value into new value, here the least value into new value. So it is surely better to add x to the least value, and finally we can return the product of answer. So even here we did not try to add x for everyone and we did not check. So from some observation we got that adding x to least value is better. So this is also a great algorithm. So let's try to discuss next one. Here is the question, read it and get it right. Alice have n balloons arranged on a rope. You are given 0 indexed colors, where colors of I is color of ith color, ith balloon. Alice wants the rope to be colorful. She does not want two consecutive balloons to be of same color. So she asks Bob for help. Bob can remove some balloon from the rope to make it colorful. You are given 0 and extra time, where needed time of I is the time that Bob needs to remove the ith balloon from the rope. Return minimum time Bob needs to make rope colorful, and the constraints are up to 1 if I. So what the question is asking, so we have a given initial array with some balloon colors. Let's assume A is blue, B is red, and C is green. So this is the color configurations. And now we have to remove some balloons, so that in the final array there are no two adjacent values with same color. So if we try to pop this balloon with third balloon with blue color, it is blue, red, blue and green. So there are no two adjacent values with same color. So the final arrangement should be like this, and the time that need to be taken to remove all the balloons should be least, and the answer for this is 3, because this is the least time possible. So For example, let's assume that the first 3 balloons are blue and the next 4 are green. So let's assume that the final configurations are BBG or BGG or BBGG. We are removing some balloons and let's assume that final configurations are one of these. So even then we have to do operations because we want any two net adjacent of the adjacent different colors. So here we have BB of same color, GG of same color, and both are of same color. So these are not final rearrangements, and surely we have to pop this as well. So if we have this initially, the final should be only of form BG because it's the only configuration possible such that no two adjacent colors have same possible color. So from each group we have to keep only one balloon and we have to remove all balloons because if we have try to keep two balloons, even then the configuration is not followed and it is wrong. So we have to keep only one balloon finally and we have to remove all the other balloons. And now we got that this is a first group and this is a mother group. And are these two groups dependent or independent? These are surely independent because even if we try to if we try to pop all balloons except one in this and pop all except two in this, it is the same case with keeping two in the final from this, keeping three from final from this. These two are independent because this is some other color and this is some other color. The only relation between these two are these should be not same colors because these two are adjacent. So we have taken this care of in the beginning itself because we divided according to the different colors. So we are sure that these two are different. So if we keep any balloon from this or any balloon from this, they are independent. So we can find answer from this plus we can find answer from this plus answer. So we want the least time to remove. So we got a group and we have to remove. We have to keep only one in the final. So burst all the balloons with least cost except the maximum value because we want the least time. So obviously we want to remove all the size minus one elements, and it is obviously beneficial to pop the balloons with least time because we want least answer. So we want to burst all the balloons with least cost except the maximum one in each subproblem. So the answer will be total minus maximum for every subcase because we have many different balloons and let's say this is the final value and we are going to remain this in the final from this group. We have to pop all this. So how to get the sum of all popped ones? So it will be simply sum of all values minus maximum value because this is going to be in the final and these are going to be popped. So final minus maximum value will be answer for this subproblem. So if we have BBB and GG, the final values are BG. The B we are finally keeping here is maximum B in this group, and similarly G we are keeping here is maximum of G in this group. So here is the code. So let's start traversing from the first value, and sum is the sum of all values in the present group, and value is the maximum value of all values in the present group, and present is the number of the color. So we are decrementing A from this to get a number, and this loop is checking for making group with the present one. So let's start simulation. Initially this is the j is equal to 0. So is s of 0 equal to s of 0? Yes, because we are checking the same index. So j will be this now. And are these equal? Yes. So we are incrementing this. And we are finally updating value and sum as well. So we are updating maximum and value and sum. So we came to this. Is b same as this? Yes. So we are incrementing the pointer now. Is b is equal to g? Is sj is equal to present? No. So we found a group. So this is independent subproblem. And we have to deal with this later. So the answer for the next problem will be starting from this. So J is this, and after completion of this loop, we are adding the answer regarding this group. So it will be sum minus value. So we are going to leave the B balloon with the highest value. So answer will be sum minus maximum. So answer is equal to sum minus value. And let's assume that there is nothing case. Oh, J plus plus. So A in J is going to increment to this. So after the loop, J is already here, and after this loop, it is going to increment it again. So we are ignoring this balloon. So it is wrong because we have to consider all the balloons. So before going to the next one, we have to decrement J because J is then in the next pointer with because we complete the iteration till this. We want the iteration from this from now. So the pointer should be this. But if we leave the pointer as it is, after the loop again it will be incremented to this. So to start the iteration correctly, we have to decrement pointer. So it will be pointing to this now. And after the loop again, it will point to the first day, which we did not compute till now. So we are using J minus minus. So the code is exactly simple. we are using a loop and we are finding the possible subproblems and we are finding the answer and we are decrementing j. So let's discuss another one. So read the question and give it a try. You can do following operation any number of times. Choose an index I and flip all elements from index I to end of the array. Find the minimum operations to make all 1. So let's assume that array is 1 0 0. If we try to make only one operation with index 1, we have to flip all the indices from 1 to n. So we are flipping all these, so it will be 1 1 1 1. So this is the final configuration, so answer is 1, because this is the least number of operations we can do for this to make all elements 1. Constraints are up to 1 and the values are 0 1. So we have n indices to flip because we have n indices and we can flip any one in the beginning. So which we have to flip at the first? Let's assume that we are coming from last. This is just an assumption, so let's assume that we are coming from last and let's check whether this can be a possible answer or not. So if the array is 0 1 0, we are starting from last. So this is 0 but we want all 1, so we are making this one and we are coming to previous value. It is 1, so no need to make any operation because it is already 1, and we are coming to 0 and it is 0, we want to make operation. So operation here means flipping all the values from that index to end. So we are making 1 0 0 again because we have to flip all this, and now again there are some zeros, so again we are starting from ending. So it is 0, yes, we have to flip, and the pointer is here, even we have to flip this again, yes. So 1 1 0, and now again there is some 0, so we can start from end and we can flip this. So 1 2 3 4. So in 5 operations we are able to make this 0, all operations 1. Is this the final answer? Surely no, because clearly we can see that we are doing waste operation, because let's assume that there is some string, there is some array, and finally erase this. So by all operations we made all the characters from last to before 1, and now we came to the 0th index. To make this one we have to make all these 0, right? Because we have to flip all indices. But again now we have to start from last because there are some zeros. We have to start from this again. So this is a very blind operation, because even if we try to make all the end values 1, if we find a 1, we have to flip all the values to the right. So it is surely the worst option. So coming from last is not a good idea. So then what is a good idea? So we observed that it is better to start from the first, because if we have done some pre-computation here and if we want some operation from this, then we have to pre-compute this again. So it is better to start from first. So let's start from first. So it will be 0 0 0 0 1 0, and initially we are at 0, we have to make it 1, yes, so we are flipping all, it will be 1 0 1. We are coming to next index, it is 0, so I have to flip this as well, so it will be 1 1 0, and now we are coming to this, so we can flip this, it will be 1 1. So in 3 operations we are going to make all values 1. This is the before one and this is the final one. So with the first, if we are trying to make operations from first, we are directly reducing these two, because 0 1 0 to 1 0 1 is one operation here. So the obviously optimal answer is to start from first. So we are just starting from 1 and starting from first index, and we are assuming that we are going to make this one, so that we cannot come back to this index again, because we make this one and we went to next index. Obviously the operations from now will be considered all indexes right to it, so this will be 1 and this will not be flipped again. So this is the best possible option. So we are starting from 0, and if v of j after all operations till now is 1, then no need to make the operation because it is 1 already. Else we have to increment the count. So what is this? Say for example it is 1 0 1 0 1, and we have done many operations, and after operations if the value is 1, it means that no need to make an operation, and after some operations if the value is 0, we have to make it. So we're incrementing count. So how to find whether v of j is equal to 1 or 0 after operations? So let's check another observation. So for example, if 0 is flipped 3 times, so it will be 0, and after 1 time 1, 2 times 0, 1 time 1. So if 0 is flipped 3 times, is it same as flipping 5 times or flipping 7 times? Yes. Because if we are flipping 1 time or 3 times or 5 times or 7 times, it is indirectly flipping once, because for every 2 times we are making to same value again. So initially it is 0, we are making one operation, it is going to become 1, and we are making other operation, it is going to be 0. So for every 2 operations, it is going to be same as initial value. So answer is same for 3, 5, 7 as well. So because anyways it is going to be 1. So if operation is 0, here it means it can be 0 or 2 or 4 or and so on. because we checked that operation is equal to operation mod 2. So if operation can be only two possible values, 0 and 1. So 0 corresponds to 0, 2, 4, 6, 8 operations, and 1 corresponds to 1, 3, 5, and so on as well. So if operation is 0, it means that it is flipped even times, right? So we have 0 and we have not flipped it. So it means that we did not flip anything and the value is same as before. So means it flipped even times, so no change from initial value. And if the operation is 1, it means that we flipped odd times and it will be 1 minus initial value. For example, if the value is 1 and we are making one operation, it will be 0. So if you are making odd operations, the parity is going to change. And if you are making two operations, the parity is going to be remain same as initial value. So let's assume that initial value is 0 and operations mod 2 is 0. So these are four possible cases. So 0, 0, 0, 1, 1, 0, 1, 1. So initial VJ is 0 and we have no operation. So it will be 0 because we are making no operation to 0, it will be 0. And if Vj is 0 and we have made odd operations till now, so value is 0 and we are making odd operations, so it will be 1. So it will be 1. And similarly for 1, 0 it is 1 and the value is 1 and we are making one flip, so it will be 0. So we assumed that we are starting from the present index and we are making this one for sure and we are going to next index because we no need to come back to this index again. So we have to make this one before going to next one. So we have zeros for these both cases, but we thought that we made 1 to the present index, so we must do an operation here because if Vj is 0 and operations till now done are even, or the value is 1 and the operation done till now are odd, the final value will be 0 and we must do an operation to make the print value 1. So we resolve this. So if V of j after operations 1, what it means that Vj is equal to operations mod 2 because if 1 in 1, so Vj is equal to 1 and op mod to 1 is equal to 0, or Vj is equal to 0 or op mod equal to 0. It means that if these both are equal, then the value is 0 and we want a flip. So this condition is nothing but if Vj is equal to operations mod 2, it means that we have to flip the possible value. So starting from 0th index, if operations mod 2 is equal to Vj, so we have to flip the value because it means that is 0, 0 or 1, 1. So we checked that these both cases, the final value will become 0. So we have to do an operation here to make this one. So hope you understand this. This is the code. We are starting from 0 and if count mod 2 is equal to Vj, we are incrementing. We are file it in the counter. So hope you understand this. If you have any doubts, ask in the comments below. See you in the next video.